Here we're going to focus on the manufacturing and supply chain. We have more content available that covers the technologies and also the applications. To talk to us today is Steve Scourse. Steve is CEO, Unilumin Group UK. Thanks for coming, Steve. What are the changes in dynamics in our industry supply chain as a result of chip-on-board technology?
Well, we first introduced chip-on-board technology solutions in the U-Mini series back in 2016. That was a whole new manufacturing process, then called mass transfer printing. So we've been developing that process since then. We had the first mass production of that process in 2018. So over the past 5 years, we've been optimizing that, improving it, and there's a whole range of things that have been done to optimize that process in terms of interior materials control, innovations in the packaging technology, improving the advanced calibration for COB technology, which is different, optimizing color consistency. So we believe that we're now ahead of our peers with this technology, and it is no longer, I would say, in its infancy. It's now getting into some degree of maturity.
I believe that Unilumin has possibly the largest LED manufacturing base in the world. Could you tell us anything about it?
Unilumin's largest factory is 400,000 square meters in Shenzhen in China. In addition to being the largest factory in the world in LED, it's also the most highly automated. We spend a lot of money, a lot of time in optimizing the production process to improve standardization, robotizing as much as we can there. So this is considered to be a sort of a halo factory within the industry. It sort of has all of the advanced features. We've subsequently opened a dedicated production line for mini micro LED, which is chip-on-board technology within that factory. Again, that's state-of-the-art, highly automated.
And if we could talk about that process a little, but mostly about maintenance and repairs. We do hear say that LED chip-on-board modules cannot be repaired. Is that true?
Well, let's start in a different place. Let's start looking at what are the failure mechanisms of LED in general. And if you look at SMD, surface-mounted devices, and IMD, or the 4-in-1 type devices, the traditional LED products, the failure mechanisms you see in those can fall into 3 areas. Let's say the first is, I would say, we call it insufficient stability. In other words, they use a process called wire bonding, which is where there's a red, green, and blue wire bond, which could be gold, could be copper. Those connect each chip to the PCB. Delamination or lack of contact within that wire bond is one of the most common failures of an LED. That requires the LED to be removed and resoldered or replaced. That's probably the number 1 issue. Then you have what we would call low-level protection. In other words, humidity is one low-level protection. I mean, SMD devices are often not waterproof, so you don't have to just keep water away from them. You keep high humidity away from them because they can absorb it. They can be affected by static. They can be affected by dust and dirt build-up from fingers and things. So all of those things you don't have in COB because it's an encapsulated technology. So it's washable, it's cleanable, it's dust-proof, it's anti-static. So it doesn't have those failures. And then you have physical damage. As the pixel pitch gets smaller and smaller, the likelihood of there being some physical damage, someone banging a briefcase into the wall, or knocking it with something, or even an engineer damaging a PCB when they put another one in a replacement. Often you can have an LED that's knocked off by the actual engineer that's replacing the one that was faulty. So you have to go back and replace another one then. So none of those things happen in COB because of the encapsulated technology, the fact that there is no wire bonding, it's a direct bonded flip chip. So because most of those things don't happen to COB, you don't have anywhere near the number of failures. So it's a very highly reliable technology. So what we call it full flip chip common cathode COB. That is the sort of the whole branding of it. So it has very high surface protection, waterproof, dustproof, static resistant, shockproof, bump resistant. Also, it is very efficient in terms of power efficiency. So that means that there's very little heat, so it runs much cooler. And as you probably know, the cooler you can keep the product, the longer the lifetime. So that's another key thing. And also it has something we call a cool screen technology, which means that the screen will never get more than about 37 degrees, even on full brightness, 37 degrees Celsius, that is, for the Americans. So that is much, much less than an SMD product, probably 10 or 11 degrees less, certainly at least 8 degrees less than an SMD with the same brightness level. So those all improve the reliability of the product. Now, to get to your question, can you repair it? In the field, you can't repair it. You can't go and repair that board in the field or even in a subsidiary office. You would then exchange it with the spare board, it's the set of spare boards that come in the spares kit with the product. But you can repair it on a dedicated production line, a dedicated repair maintenance production line. So we have such dedicated production lines for repair using automatic chip removal, automatic bonding, and that's all in the factory. So today, for repairing the boards that need repair, they would ship back to the Shenzhen factory. They would be run through that production line to remanufacture effectively there. So you end up with a line that we can do about 100 modules a week there. That's the turnaround time. I shouldn't say that's the capacity. That's the turnaround time. If someone sent 100 modules in, it would take about a 1 week, 7-day process to repair them on that production line. And then they ship out again as fully repaired, basically remanufactured product.
Thank you. That's interesting rundown of it. Could we talk a little about the costs that surround it? Are things like mini LED products, are they on the expensive side?
They were. When we first entered mass production with the U-Mini 0.9 back, say, 2018, it was premium priced. There was a significant premium for the COB U-Mini compared to the premium level U-Panel S, which was the high end of the SMD product line. That is no longer the case, and part of that is down to the fact that, as I said in the beginning there, it's the maturity of the production process. The yields are now higher. The supply chain is also more mature, so that is, the costs in the supply chain have come down as well. So now you have a solution where you have, in say, the U-Mini Pro, which is the latest iteration, which is the third iteration, the third generation of U-Mini products. You've got the extreme high brightness, extreme contrast, very high efficiency, very high reliability, high robustness, great viewing angle, and you've got a product that is comparable or even lower cost than an SMD product of the same performance or similar performance and the same pixel pitch.
Absolutely fantastic then. Thank you, Steve, for all that information. Very insightful.